Hi guys, welcome back to the channel. So in Excel, most people think of this as multiply and this as addition. But in Excel, you can use them as logic operators. So with just these two symbols, you can replace complicated and or functions and even supercharge dynamic array formulas, such as XLOOKUPs, index matches, filters, and SUMPRODUCTs. Let me show you how. Jumping on over into Excel. So let's have a look at some simple Boolean logic in Excel. So Boolean is where we get true or false results. I've got a couple of names here. We're just going to test. Is the name in column A equal to Ben? So we'll say equals if A4 to A5 equals Ben. If it's true, we'll just have true. And if it's false, we'll have false. So you can see we've got the true on the row with Ben, and we've got the false on the row with Tom. So if we were to refer to those results like this, you can see we simply get the true or the false again, so the Boolean result. Now really under the hood there's a binary value, so binary being ones or zeros, attached to each of these true or false values. And the way to see these is if we do equals, and if we use the double minus, brackets, this value, I'm going to use this array, close our parenthesis, and then you can see the associated binary values to those Boolean true or falses is actually ones or zeros. So you're probably asking yourself, okay, but what use is this? So I've pulled together a little example here of an XLOOKUP where we're going to delve deeper using these binary values from our Boolean true or falses. So what I'd like to do here is write a formula that's going to give us the result from this column for where these variables are true. So where Ben is the first name and where Jones is the last name. So how could we do that? So we're going to write equals XLOOKUP. We're going to look for that value of 1. So 1 is going to be where we get a true result. I'm going to show you the full breakdown of this after, so bear with me. We're going to look up within an array of where our first name array, so A4 to A8, equals to Ben. And we're just going to wrap that within parenthesis. And then because we're going to do AND logic here, we're going to use a multiplication. We'll cover this in more depth in a second. And we're going to multiply it by where our last name array is equal to Jones. We're going to close parenthesis on that. And then our return array is going to be our results. So if I close our parenthesis on our XLOOKUP, you can see now we get the result Ben Jones result, which is the right result for that particular row where Ben is the first name and Jones is the last name. So that's good, that's working, but why is it working? Why is this 1 returning us the right result? So in our formula where we've got A4 is equal to I4, I'm just going to steal that bit of logic and I'm going to put it in here. So that's spilling a true and false array, so Boolean results, remember from the first little example we looked at. So that's saying that where Ben exists in this column, it's true for this row, the second row, but not the row 3, 4 and 5. Then if we go back into our formula, I'm just going to steal the second array that we wrote for our last name. And I'm going to put this in here. Now this is looking at where Jones is correct in our last name array. So you can see it's correctly told us the Boolean results for that row 2 in our table is true. So then what we did is we multiplied this array by that array to give these binary results. And then if you cast your mind back to why that is working, if we look under the hood of these, we can see the binary results by forcing them using the double dash. So our trues become 1s, our falses become 0s, and again, our trues become 1s and our falses 0s. And then when we multiply 1 by the other, we've got 1 times 0 equals 0 on the first row, 1 times 1 equals 1 on the second row, and so on. And then, so our XLOOKUP, where we're looking at 1, if we were to look at this column, it would tell us this row, Ben Jones result. And that's exactly what we've done within this formula. If we were to evaluate the lookup array you see it's 0, 1, 0, 0, which is what I've just illustrated in this multiply column here, 0, 1, 0, 0, 0. And if we were to evaluate the individual arrays, you'll see your true, true, false, 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 which is our true, true, false, 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 and so on. And that's true for this one as well. So that's how we can use the binary logic to look up the value of 1, where we've got a true result for these two arrays multiplied together. So that's the equivalent of doing an AND. So we've said we want the result where Ben is the first name and Jones is the second name. What if we wanted to do an OR logic? So to do the OR logic, pull together an example here. So we're going to do the same concept. We're going to use an XLOOKUP and we're going to look up for the value of 1 again, because we know that's where our trues lie. And our lookup array this time is going to be the first name again is equal to this first name here. Remember to wrap in parenthesis. This time, however, the difference being we're going to put plus instead of multiplication. So that plus is going to represent OR. And again, we'll dive deeper into why that's working after. But let's just finish building this formula. And this time, we're not going to use last names. We're going to say where the first name is equal to Jane or the first name is equal to Joe. So our first name array again, and then equal to Joe. Close our parenthesis, comma, so we go into the return array, and then our return array will be the result again. So we close our brackets on our XLOOKUP, press enter, and you can see where we're looking for Jane or Joe, we've got Joe Greg results. And that's because XLOOKUP's default behavior is to return one result starting at the top of your array. So it's gone down this array, found Joe's the first one out of Joe and Jane and given us that. Likewise, we could do a search mode of last to first, which is a -1. And then we would get Jane's result like that. Again, let's get under the skin of this. How is this actually working with OR logic and the additions? So we're going to steal these two mini arrays and we're going to see the individual results here. So Jane was our first argument, and you can see we've correctly got the true down on Jane. And then we looked for Joe within that same array. So I'm going to press F2 to edit the cell. Then we've got the true against Joe, that's right. So now if you remember in that formula, we've done a plus, not a multiply. So let's replicate that. So we're going to do this array plus this array. Notice I'm using the hash identifiers because these are dynamic spill arrays, so the hash automatically recognizes the size of those arrays. And then we have these sums. Just to make those clearer, we'll do like we did in the last one. We're going to force the binary values using the double dash to make this example clearer to explain. So you can see at the top we've got 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1. So then we've got two rows where we're getting our 1. And that's why when we search from top to bottom, we get Joe. And if we search bottom to top, we get Jane. There's other instances where this binary lookup logic applies. So again, we're going to do the same thing. We're going to look where the first name equals Ben, the last name equals Jones, and we want to return our corresponding result. So index, going to index this result array. And then to find our row number within that index match. If you're not sure how an index match works, you can check out my other videos where I've covered this. Do XMATCH, and we're going to look for the value of 1, just like we did with our XLOOKUP. It's our lookup value. Our lookup array, we're going to open parenthesis. We're going to use our first name array is equal to Ben, exactly the same as we did in the XLOOKUP. We're going to multiply, because we're doing an AND, remember, which is multiplying our arrays, not adding our arrays. Highlight our last name array where it's equal to Jones. Close our parenthesis on that. Close our parenthesis on our XMATCH, and then close our parenthesis on our index. And we get Ben Jones result as expected. And we can just have a look at how that looks with our Boolean logic. You know now we're getting the trues on our first name and last name, which is 1 times 1, which gives a 1 in our first arrays, which we can demonstrate by highlighting our XMATCH, which tells us that's going to match row 2 from our original array of those results, because this array is true, true, false, 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 multiplied by our other array of false, true, false, false, false. Just gives us that single 1 on row 2. Moving on, we can use this with the filter function. So if we were to do filter, we're going to filter our results array. This time we're going to use OR logic. So to include, we're going to do parenthesis on our first name equal to Ben, close our parenthesis on that, plus our arrays together, so we've gone to ORs now, use our first name array again, equal to Joe, close our parenthesis on that, close our parenthesis on our filter. Now we should get a spilled array of where the first name is either Ben or Joe, and as you'd expect, you've got these 3 results linked to those 3 first name matches. Some products work well with this binary logic on arrays. This time we're going to look for where the first name is Ben or Joe, and we're going to aggregate the age of those individuals. So we're going to do a sum product, open parenthesis for our first array, which is going to be where the ages live, close that array, and then we're going to nest within our second array. Our first names are equal to Ben, and remember we're doing OR logic here, so you know what comes next, a plus. Our second criteria is again within that first name array, but Joe. Close our parenthesis on that, close our parenthesis on our nested addition array there, and then finally close our parenthesis on our sum product. Click enter, got the result of 157 for the ages of anyone where it's Ben or Joe. And if we just test that with a simple sum of these 3, get the 157 as well. Okay, so one question you might be asking throughout this video is, why are we not using the built-in functions called OR and? Why are we replacing ORs with pluses and ANDs with multiplication? Now the reason for this is for arrays to work, we need to convert those arrays into those binary values, and I'll just illustrate that. So here we're just going to do a static formula to test whether this cell is equal to Ben, which it would be. We also want to test whether this cell is equal to Joe. Now for this to work, we need to wrap this within an OR, and it becomes OR logical 1 or OR logical 2. So we'll close that OR logic off to go back into our if. And then we're just going to return Ben/Joe if that's true, or we're going to return neither if it's false. So we'll close that, and we can commit that formula down there. That all works fine for those. However, it's a static formula, which isn't ideal when we could write a dynamic array. So let's copy that formula, press F2, Control V and enter so that we can steal it. However, this time we're not just going to use an old school static cell reference, we're actually going to use arrays here. Now you can see the problem is we're not getting a spilled result here across our 5 rows, we've just got a single result here, and that's because the OR function is an aggregator. So this is aggregating the results of that array into one cell, and we want it to spill over 5. So that's the problem with ORs, and exactly the same thing with AND, why that causes problems with arrays. And then if we were to repeat that logic using our multiplication and addition, so we'll just steal that same formula and pop it in here. What we're going to do is we're going to get rid of that OR, and we know that we can say within brackets that array, get rid of the comma. We'll put our addition in because we're doing an OR. Wrap our second set of logic within parenthesis. Again, we'll step into our true or our false with exactly the same result. So if we hit that, you can see now we get that nice dynamic spill array that we were looking for, and we've got the same results that we got in that static cell referencing at the beginning using OR, and we've overcome the problem where OR was aggregating our spill into one result instead of 5. That's it. With those 2 simple operators, plus or multiply, you can unlock some seriously powerful features within functions. Now it's your turn to try it out on your data, but before you go, please hit that like button if you found it useful. Press the subscribe button if you're not already, and I'll be back with you again next week for some more helpful tips and tricks. Thanks for watching.